What's the name here?
I've got a little problem with
Is someone using this chair?
well, how do we set up that code?
Okay, so I think we can get started right about now. So hello everyone, this is the third programming workshop, and we're doing a lot of physics and collision stuff, which is very important because this is the main way you move basically anything in a Unity game, most of the time. So if you haven't already, I probably should have posted this, go ahead and clone the repository. It should be somewhere in the programming workshop. You might have to scroll up a little bit. But yeah, just go ahead and try to set that up as I'm kind of doing this. And open it up. Yep. Okay, so I believe Wayne's going to be posting it pretty soon, but in the, do you have the repository open? Are you in the Discord? Yeah, you're right there. So in the programming channel, I should have posted it a little while ago. Scroll up more. Right there. Wayne's going to post that again, hopefully. But yeah, just in the meantime, let's get started. So we kind of left off last time talking about vectors. And vectors are pretty important to talk about for physics. The vectors in Unity are a little bit different than they are in like a physics class because they don't really hold a magnitude and direction. They're just kind of one thing. So in Unity, vectors just hold three components, the x, y, and z of something. So your position can be expressed as a three-dimensional vector, which is the vector 3. And it's just basically a container for three numbers. You can create one just like this vector 3 my vector, and take note of that new keyword because you're basically creating a new class or a new object of a class if you're kind of familiar with that terminology. So yeah, basically this is how you kind of create vectors. The vector 3 is a three-dimensional vector. It has x, y, and z for 3 dimensions. There's also a two-dimensional vector, which is used a lot in 2D physics. And this is just an x and y component. You basically just don't have a z. And making it's pretty similar. It's just instead of vector 3, it's vector 2. So yeah, new vector 2, you can make it however you want. So we can use these vectors in a lot of ways. So we can add vectors together, subtract vectors together, multiply and divide vectors by a scalar, which is just a single number, not a vector. You cannot multiply and divide vectors together. That's not kind of how they work. But yeah, most of the time you're just going to be adding together vectors or multiplying by a scalar. Anyone have any questions about all of this so far? Okay. So quick note, you can, instead of using transform.translate, you can set position and set rotation and set scale manually using a vector 3. But we're not going to be, we're kind of moving on from transform, so this is just kind of a quick note. You don't really need to know this. Come on. OK, mouse died. So now we're going to get into actual proper 2D physics. And so how Unity deals with that are a component called Rigidbody.2D. And if you have the project open right now, wish my mouse worked, you can see on each one of these components, except for the trigger, there's a component called a Rigidbody.2D. And basically this component just kind of tells Unity about the kind of the physical attributes of the object. So if it's a dynamic rigid body, then it's going to have stuff like its physics material, which covers stuff like its friction and so on, and basically how much it weighs and its mass and so on and so forth. So that's kind of what a rigid body does. And every object that you want to move around physically needs to have a rigid body. So there are 3 types of rigid bodies, and they're controlled by this drop down right here, this body type. You can set it to any 3 of them, well, any one of the 3. And the 3 are dynamic, kinematic, and static. Dynamic rigid bodies are basically the simplest. They are affected by gravity, and they have a weight and a mass and so on and so forth. So basically, if you just have want to have a ball like bouncing around, just being affected by other objects, then that would be a dynamic rigid body. The second type is a kinematic rigid body. So these are a little different. So they still kind of interact with physical objects. Like they can move around dynamic rigid bodies, but they aren't affected by gravity or forces. So you can kind of think of it as an object with infinite mass. So you can basically say, what you can do with this is if you want a lot finer control over how your object moves, then you can make it kinematic. You can reposition it however you want, apply whatever velocities you want to it, so on and so forth, and it won't be affected by any external forces. So you have a lot of control over that. However, you do have to kind of do a little bit extra work in order to get it to move around. Because it's not affected by gravity, you kind of have to program whatever forces you want manually onto it. And then the third type is the static rigid body. And static rigid bodies are just rigid bodies that don't move. So dynamic rigid bodies can collide with these static bodies, but aside from that, they don't really do much. These are really good for, say, ground. If you have like a 2D platformer, then your ground would be a static rigid body. You don't really ever want it to move, but you want things to interact with it. Any questions on these 3 types? Yeah?
What do you usually use kinematic for?
So sometimes you want a kinematic body for a character controller. Character controllers can either use dynamic or kinematic based on how fine you want the control of the character to be. So if you have a dynamic rigid body, then you're kind of controlling it, but not really, because if you like hit a wall, then you're going to be forced back. You can bounce, you can do all these things, and you can kind of negate some of those with the attributes, but they're still going to be acting upon it. So if you don't want any of that, you can use a kinematic rigid body, still interact with the physics engine, but you have more control over it.
And dynamic is more easy for you to like do now, so use dynamic now.
Yeah. So dynamic rigid bodies are a lot easier to set up. So for your character controllers, if you want them to be like physical, you want to use dynamic for now. If you're finding that dynamic doesn't give you as much control, you can look into doing a kinematic rigid body for a character, but typically you want to be using dynamic. Any other questions on that? Okay. So what you can do with a dynamic rigid body is so in this scene, we have one dynamic body, and it's this box right here. And if we hit play, then we can see it kind of just falls. And if we go ahead and turn that, we can see that it's going to bounce and then rotate back down. Sometimes you want to kind of fix some of these in place. Thing. So what you can do is freeze its rotation or its position. So if I freeze its Z rotation, then go ahead and play, then it's going to fall down, but it's not going to rotate anymore. This is pretty useful for just kind of standard player characters that you don't want to be like rolling off the edge if you go too far. So yeah, and I can turn that off and it'll fall back down. So, in order for all of these rigid bodies to kind of work together, they need to know the shape of all the objects. And what gives your object shape isn't actually its visual component, but it's something called a collider. So these colliders are basically just like simple shapes that kind of describe how you want your object to collide with another thing. So if we go into here, we can also see all of these objects have collider components. So all of these just have box colliders because they're all boxes, but there are different types of colliders, which you can see in Physics 2D. So we can see we have a capsule collider, we have a circle collider, and there's also a polygon collider, which you can kind of make more complex shapes with. The reason these are kind of limited to more simple shapes is because calculating collisions is very performance heavy, so you don't want to have something with like all these different curves and edges to be colliding with anything else, because that's a lot more vertices to kind of calculate in your collisions. So you basically just have a box that like contains your object, and that'll be used for collision detection. So we can kind of demonstrate this by editing our collider. So if we make this this collider for our box bigger than it should be, and we let it go, then it's going to stop before it actually hits the visual component. So the collider and the visual component are completely separate. A lot of you may have been, played online shooter games that have weird hit detection, where you shoot something but it kind of misses, but you're sure you actually shot it, or maybe you shot above something but it actually hit them. And that's because the hitboxes on, or these colliders that are on that object, are slightly bigger or don't 100% represent the shape. And so that's kind of the same thing that's happening here. Does anyone have any questions on how colliders work? Yeah.
Can you, are you able to assign different types of colliders? So one for damage and then one for traversing, right? And stuff like that?
Yeah, so we're kind of getting into that later. So you can have a collider that doesn't actually affect physics, and that's just making it a trigger. So if we make this collider a trigger, we also have another trigger right here, then that collider is no longer being used for physics, and you can use it for other things. We'll get into that in a little bit. Any other questions on that? Okay. So yeah, basically do that. So using these in the script is basically just like using any other component. You have to get the rigid body component from the object. And since your scripts for rigid bodies are typically the only thing you really want to do with that object, you typically want to store it in a easily accessible variable. Typically this is RB, but it can be anything you want, RB for rigid body. And that's kind of what it would look like, RB equals get component rigid body. So one of the most important things we have for rigid bodies is setting its velocity. So the velocity is basically going to be calculated every frame, and it's going to be used for kind of knowing where the object goes. So you can actually set this velocity, and then it's going to be changing after that. So if you have a dynamic body and you have it kind of flying through the air, you can set it to another velocity, and then it's going to recalculate everything and then start going with that velocity. You can also set velocities for kinematic rigid bodies, and those are just going to kind of stay constant. They're not going to move without you moving them. Yeah. Come on. My mouse is dying. Okay. Something we can do with only kinematic rigid bodies is move position, and this takes a vector too, as did the other one. So move position is basically like setting the transform.position, but you don't want to set transform.position when you have a rigid body, because if you have a rigid body on something, you want the physics engine to take care of it only. Setting the actual transform is going to kind of cause a lot of problems, because the transform doesn't always match up with how the physics engine wants to move an object. So you might get colliders that are misaligned and all this other stuff. So if you have a rigid body, stay away from transform and use only physical functions. And for the kinematic body, you can move position. You don't really want to use this on dynamic bodies, because you want dynamic bodies to only really be affected by forces. But if you want to like teleport something or so on, that's something you can do with kinematic bodies. So for our dynamic bodies, you can add forces. And so this is basically just like pushing something over a certain time, or like punching something really hard. That's just going to add a force. So there's one function for this, and it takes a vector 2, but optionally it takes a second argument, which is a force mode 2D. And what that force mode 2D is, it can be one of two things, either a force or an impulse, I mean. So basically what the force is it's going to apply an acceleration over time. But an impulse is going to add an instantaneous force to that object. So think pushing something over time, or like launching something. So if you want something to, say, like jump, then you kind of want to use impulse. But if you want to start moving something in a direction, then you want to use force. Does that kind of make sense to everyone? And this is kind of how you would do it. You would say rigid body dot add force vector, and then force mode 2D dot force. Or you could do force mode 2D dot impulse.
In a first-person style game, when you want to dictate movement, are you using force to dictate forward, backward, sideways?
That depends a lot on the feel that you want for the game. Oftentimes, you're just going to be setting velocity or moving the position yourself for a character controller. But if you want your movement to be a little bit more floaty, then you're going to be kind of influencing it with forces and letting acceleration and deceleration do their thing. Does that make sense?
Rolling a ball, for example.
Yeah, but also there's like, say, flying through the air. You don't want to kind of be, you want to be letting the physics engine do its thing there instead of just like setting it. Does that make sense? Okay. So, we can kind of demonstrate all of that with our, let's see if I can get my mouse to work again. So, let's set this back to its original position. So, in our project, we have two different scripts, one for the player, which is this kinematic body, and one for this box, which is a dynamic body. So if on start we say set the rigid body velocity to a new vector 2, and say we want it to be going up, so we would say set it to 0, 5. And if you're in your project, you're going to have to drag the box script onto the box. I kind of forgot to do that. But if you're manipulating box script, just drag it onto the box. So if you go ahead and run that, then our box is going to jump up first and then go down. And that's how you can use that rigid body.velocity. So if we did the same thing on the kinematic body, so say rigid body.velocity new vector 2, 0, 5. So this is on our kinematic body. Can anyone guess what this is going to do when I hit play?
Nothing.
No, it's going to do something. What?
Just gonna go up and keep going now?
Yes, exactly. So this isn't affected by forces, so if we set its velocity, it's going to go up. And so how that would work for like a character controller is you would want to have the forces that are kind of affecting it be programmed into your math that you're doing. So if you wanted that to be affected by gravity, then in your fixed update, then you would be applying gravity every frame yourself, or every update. Does anyone have any questions on how that works?
So related to gravity and physics-based engine, I don't know if you've already covered that or not, but if you have a character that jumps, for example, you're applying an impulse.
Yeah, so you would be applying an impulse force up, and it would be keeping its x velocity, but just that force upward as an impulse would give it that motion.
Okay, and what about gravity bringing the object back down?
That's automatically handled if you have a dynamic rigid body.
When you have objects that have mass in a game, for
Yes.
example, and you want to convey that they have gravity actually.
Mhm.
So if you strike an object in an FPS and you see a box that rolls, for example, perhaps the strike would be denoted by the impulse.
Yeah,
But what
so
about, gravity causing the object to act like an object with mass? How do you
that is just a dynamic rigid body. So this box has a mass, it has a dynamic rigid body, and so if we just let it go, then it's going to be affected by gravity. So we're applying a velocity in, initially, but as you can see, gravity just brings it back down. We didn't script any of that. That's all just the physics engine doing the physics engine thing. Right? Does that answer your question?
when does the green box come back down?
The green box is not a dynamic body.
Oh.
We kind of covered this a little bit earlier, but the green box isn't affected by forces. It's still in the physics engine, but it's not affected by gravity, other forces, or anything. So think of it as an object with infinite mass. So nothing's going to stop it but itself. So you script all of the forces and velocity that has to do with that green object.
Okay.
Okay.
Question here.
Oh yeah.
If vector is not considered a force, what would be a force that wouldn't affect the kinematic body besides gravity?
That would be you setting the velocity yourself. So in our player script, we set the velocity, and you can set the velocity manually. It's just the physics engine isn't going to touch it for you. For a dynamic rigid body, you can set the velocity, but the velocity is going to change outside of what you're setting it. For a kinematic body, you always know what it's doing because you set it to do that. Right?
Yeah.
So for now, only use dynamic.
Yeah, so dynamic is a lot easier to use, like I said. You typically want the physics engine to do its thing, but if the behavior you want kind of isn't working with the physics engine, then you want to use a kinematic body. It's more of an advanced behavior. So now we're going to get into functions related to collision. So this is where things can get pretty interesting in the physics engine. So we have this onCollisionEnter 2D function, and this can be found in our box script. So, I just closed it. Oh, there it is. So we can see this little function down here, void onCollisionEnter 2D. This is pretty similar to the other functions like start and update. This is going to be called whenever it collides with something. So the floor, a kinematic body, another dynamic body, anything. Whenever that collision happens, this function is going to run. And so you can do whatever code you want. You can print something to say, okay, this collided, or you can kind of apply another force. So if you want, say, an impulse to be done when you come in contact with something, then you would do that here. So there are two other functions just like this, and this is pretty similar to the button functions, where we have an enter function where it's only going to be called once as soon as the collision happens, and then a function where it's going to be continuously running as the collision goes on. So if you're like dragging something across an object, that's going to be running on collision stay. And then on collision exit is only going to be run when the collision stops, when they kind of separate. And so say you wanted something to happen whenever, like as long as your object is in contact with something. Say you want different behavior based on whether you're in the air or on the ground. Then in this on collision state, you would be having, say, okay, I'm on the ground, and then on exit, it's going to do that. Okay, I'm no longer on the ground. Do some different behavior. Does anyone have any questions about how that works? Yeah.
So as an example, would it be like if your player character runs into a box and you wanted the character to pick that box up?
Mm-hmm. Yeah. So you would have on collision enter, then whatever behavior you want, like parent the box to the player or whatever.
Nice.
Question?
So that's just like a kind of listener, right?
Yeah, you can kind of think of it that way. So as soon as this thing happens, then it's going to go into your code and run that code. Any other questions? Yeah.
If you were to add a script that said on collision stay 2D to an object that didn't have a rigid body, would it still be able to run that script?
No. So this, you can only have collisions between things if they're in the physics engine, and anything without a rigid body isn't being affected by the physics engine.
Wait.
We're getting into something that can do that pretty soon, yeah?
No, it don't need to have rigid body, but it need to have a collider. And if you want two objects to like collide with each other, at least one of them need to have a rigid body.
Okay.
So if this doesn't have rigid body, another object must have.
Okay.
So, right, any other questions? Is that good? Okay. So, something cool we can kind of do with this is we have a system called tags. So if we go into our scene and we kind of select one of these, in our inspector at the very top, we can see a little tag area. And so you can kind of set a tag for an object, and you can like add tags, just all that. And what this does for us is we can actually filter collisions based on this. So say you wanted your player to have a certain behavior whenever they're on the ground, but not the same behavior if they're touching a wall or touching a box or something else. Then you would have a tag called ground applied to everything that you would consider ground. And so inside of our onCollision enter function, we can have an if statement where like if our if the thing we collided with has the tag player, which is our collision.gameObject.tag, this would be ground in our scenario, then we would do something. We would say set a Boolean or do whatever we want. So that's pretty useful for filtering collisions. So we can kind of demonstrate that where in our box, we can say so if our other.gameObject.tag is ground, and we can see that ground, and if we go back into this, we can see that our ground object right here has the tag ground. Then rb.addForce, new new vector 2 and 0, 5. Force 2D. Oh, no. impulse. So this is pretty self-explanatory, but now when we hit play, if it hits the ground, it goes up. So now it's bouncing. So we can see that this kind of works if we go into our player and stop it from moving. And remember that kinematic bodies do collide with dynamic bodies. So if we put this over our kinematic body, then it's just going to sit there. And this on-collision enter for our box isn't going to be running because the player doesn't have the ground tag. Does that kind of make sense with everyone? Yeah.
Is this how you said like jump only when you're on the ground?
Yeah, so you could use this to say, if you enter a collision and the collider has the ground tag, then you can set your player's state to being on the ground. And that can enable all sorts of functionality, like you're able to move, you're able to jump, all this other behavior, and that would all go in update, but you would have a different state set when you enter that collision. Does that make sense?
Okay, so going back to the bounce that you just programmed, where you have this bounce that remains constant. If you want smaller bounces, like an object, like you're throwing a bouncy ball, for example, and each successive bounce is smaller than the first because of gravity, how would you program it?
So then you're not going to really be using a function like this. So you would set the bounciness of the material of the object and just let it keep bouncing. There's nothing you really need to program to do that. That's all kind of handled by the physics engine, the box's material, so on and so forth.
There's a bounciness method.
It's set in the editor, and we don't go over this today, but we can unfreeze our rotation, kind of set this back to 0. And it's probably not going to be bouncing, but yeah. Oh no, I don't think that's safe. So it kind of just phases in there, but if you had a different physics material, which is set in this physics material 2D right here, of which we don't really have any, and we're not really going over that today, but you would have a physics material that kind of states, okay, so this object is very bouncy, and whenever it collides with something, it's going to be bouncing around. That's kind of how that behavior would work. But yeah, we're kind of going over that later. Does that make sense?
I think so.
Any other questions on that? Okay. So now we're getting into triggers. So essentially what triggers are colliders without rigid bodies. They're not going to be moving with the physics system. They're just kind of stationary, invisible colliders that, I mean, they can move with the physics system, but typically they don't. So how you set these triggers up is they're just colliders, but with something set. So if we go into our bad trigger, we can see that it's just a box collider with is trigger set to true. So the effect of this is that things aren't going to be colliding with it anymore. They're going to be passing through it, but we can do something called on trigger enter 2D. So basically what this is if an object kind of passes into this or like through this area that you've set, then you can do some sort of method or behavior or whatever. And these are pretty similar to the on collision enter with the on trigger enter, on trigger stay, on trigger exit, so on and so forth. An important distinction is that the argument is no longer a collision, it is a collider. So it returns the object's actual collider component that we can see here. And those are slightly different, and you can kind of look up what exactly is in a collision in a collider. But basically for the collision, for the collider, we can just kind of get its game object directly and so on and so forth. Does that kind of make sense? So what I can do here is I made a trigger script and I applied it to my trigger up here. So let's position this box right over our trigger here, and in our onTrigger enter 2D, we can get the I2D other RB equals the collision dot get component rigid body 2D. So what this does is now we have access to whatever is inside of this, their rigid body. So now we can do something like other RB dot add force and new vector 2 0. Let's do 5 0, and then let's make that an impulse. No, we just say impulse. No. Let's go 2D impulse. So now what this is going to do is whenever we hit play and this object kind of comes into this trigger, it's going to shoot it to the right. If you saw that, I can kind of play that again. Shot off to the right. You have a question?
Oh, I didn't see that.
Yeah.
So you have a vector that's a horizontal vector that's also
Yeah, so we have our vector 2 here, and it has a 5 in the x-axis and 0 in the y-axis, and we know that it's an impulse, and that force is being applied to whatever rigid body is inside our trigger. So we can like duplicate our boxes, and every box that's going to go in here is going to be shot to the right. So stuff like triggers are pretty useful for like areas of the map that you want something to happen. So like say a door, if you enter this area, then the player is going to be transported to a new scene. Or if there's like an exit to a dungeon, or if you want an area that hurts the player, so on and so forth, those would kind of all be triggers. So whenever the player enters, something happens to the player as they're in there. Does that kind of make sense to everyone? How that would kind of be applied?
The trigger was the red box, right?
Trigger was the red box.
Just wanted to double check.
And we can see that this bad trigger here has a collider. It doesn't have any sort of rigid body, and it has trigger enabled. If we just disable that trigger, then nothing's going to happen. It's going to be colliding with that collider, and so on.
Got it.
What did the script look like again?
So we've got onTrigger entered 2D. And we're going to be posting the slides like really quickly and then very soon, and then doing an activity. So yeah, so I'm just going to go. So right now we can do an activity. So basically, just kind of play around with all this in the scene. So these are some of the things you can try. Moving things with your input axes. So like moving the kinematic body whenever you press D. You can add impulse forces to like jump, and you can have different collision shapes. Try out changing gravity, so on and so forth. These slides are going to be posted again in programming really soon, the programming channel. So as you're kind of doing this, you can go to different parts and kind of have a reference, and just kind of try implementing something, do one of these things. And we'll be around kind of answering questions and helping. Does that make sense? Okay, you can go ahead and do that.
I think it's an older version. I just didn't want to have to
Our repository, I think it works.
It's like every 2 weeks.
You need to. So you need to go into scenes. You need to open this. It's a and just open the scene. Yeah, just double click that.
That's how Visual Studio feels.
Just
to me. It was like,
cancel this. This is just an empty scene. So double click on this.
That's fine.
Yeah.
And then
And hit don't save.
select.
And there it is.
Yeah, this is not right.
Anyone else having trouble with the repository?
So is the on-trigger entered in the box here?
Trigger
No, this
because
was
the
the
box is not a trigger.
template that he's or
And you
that he has in
put
this
it there.
one.
Okay. Yeah. So on trigger, and then
Yeah, sure.
you need to drag
Do you
that
have
to your
do you
trigger
have this?
This one?
Yeah.
Yeah. And there's a Discord for VGDC.
I did 5 times on. Okay.
Could you show me what it says in that script we're working on? Because
It's in the slides. So.
I don't think it is. It says this, but what you had.
Oh, okay. So yeah. One second. So it's it's right there.
Okay, thank you.
So,
If you don't know,
yeah, probably.
Yep.
I'll try to get it to bounce when it hits the ground.
Can I see your script again?
For Discord.
yeah.
And you changed it in the editor? Yeah, so
I just saw you responding.
Oh, yeah, you're
it's
already
adding
on that.
force, so you kind of want that to be
So where do we find?
So just go
So
ahead
your second
click
argument
here,
is
just
force mode 2D.
and then the Git template should be in the programming tab. It's further down. Let's see. Scrolling. A little more. Right. So just click on.
Yeah, you can
Do you
change
have a
the
Git
direction of that vector. Yeah. So it might not be impulse triggers. So you have a couple different differences there. So if you go back into your script,
Do you have Git?
you want something to be
I guess
going
down
as
as
long as
but
it's
what I like is
So instead of
I
trigger,
get
it would be on
desktop so I can clone those projects, and then I have a Git folder that it gets.
You can just change it. The actual function. So you change that from on-collision wire to on-collision state.
Okay. And then do you know where that folder is?
So if you can do on-collision state, do you want it to be slightly on?
Okay. Yeah, just keep that trigger.
Yeah, so this is
And then go ahead and open
as long as there's in the
I'm not sure if you can open up the project from the folder, but go ahead and open up Unity.
Yeah, and so those are being applied as impulses. If you want that to be done like over time, then you would delete that impulse and it would apply force over time. So those are just yeah, you can just play around with it.
Oh yeah.
Did you have a question?
You had a question about the different types of bodies.
Yeah.
rigid body, kinematic body, and dynamic body.
It's well, rigid body is all of them. You have a dynamic body, kinematic body, and a static body.
Okay. So rigid body is the parent class.
Basically, yeah. So they're just all different types of the same thing.
So if you have an FPS with a character control, what kind of body?
It's really up to the behavior that you want. Typically, those are going to be static bodies, not static bodies, kinematic bodies, because you don't want unexpected behavior in your game if you want tight controls. So if you only want like very specific, like you're sprinting, you're running, but you don't want to be like bouncing all over the place or like accelerating too much, then you're going to be having a kinematic body, and you would have functions for when you're in the air, functions when you're on the ground, lighting of things, and so on and so forth. But what's easier to implement is having that be a dynamic body, where it's kind of taking care of your gravity for you, and if the light is up, you're going to stop, and so on and so forth. But having a dynamic body, you don't get quite as much control over that behavior, because the physics engine is as well. Does that make sense?
Instead of like translation language, just right
Yeah,
up
you have
there,
an
make it
option.
seems like it is carried.
I haven't seen an
Yeah, so I think a really good way to describe the difference is, have you ever played Quake? So stuff like Quake and Wolf and outside of lesser extent, but
If we still want to like
yeah,
keep alive as
so
programmers, we will not want to do
the
that.
Duke character
So
control,
what I would do is
Quake, Team Fortress 2, stuff like that, where you have a lot of
have some
really
script to manage the
physical behavior,
things.
where you're jumping across the map or like colliding with things, you're moving really fast.
And if I pick up
That
something,
kind of
I should have
really
some
extreme behavior
data structure or
is
something
all
to
being
store the
dictated
item.
by the
Okay.
physics
And
engine. That would be a good
George
choice for a
used
dynamic
programming
body.
on my head.
But
For
something
example,
like
I
Call
had
of Duty,
another script on
where
my head.
you're not having that
I
kind
may
of control,
remove the
you can
kind
only
of
really go
because
forward,
if I
like
have
slide along things,
so
and
many
so on and so
things,
forth. That would be a
and
good
they all
choice
have
for a
titles,
kinematic body,
and very weird.
because you want that
Actually,
finer
sometimes
control.
we want to do so.
Right.
But it depends on the situation.
So you're saying
You actually put another object here, but you need to calculate its transform position to make sure it's always
So,
on my head.
like,
That's
if I
what
get like
we did during the game jam. Like we had
around
a bunch of
to the right, but the art thing,
you need to write like some code to calculate
It's staying consistent because you're applying the force every time it's the ground. So there's no loss of anything. Yeah.
it's just
If you wanted that balance, don't know it just being controlled by the physics engine and having the actual forces you have the physics material applied to it, and you wouldn't have any force
object.
Does that make sense?
Yeah, so there's no way if I like wanted it to go farther in each bounce, what
Yeah,
is
so
that?
the only thing that we
Farther
get right now is
so
these
adding
We can make it
each
more
of these
force,
and this one is
so
the dynamic one, so it's affected by gravity. This one's the kinetic, which is
So-
whatever you want.
Yeah, so there is friction actually.
And it's not going to be
And
affected by
you
gravity.
would
Anything that's usually,
apply a
and this is the this red thing is the static body, which does not move.
applying force. Can I see that again?
Yeah. Because I'm doing that half force through impulse. But then I was like, oh, this is like how we get into that action, so shouldn't it go farther each time? That's just all based out, but yeah.
Depends. If you only have, for example,
Yeah,
this
so
game,
can I see
here,
the
only
forces?
pick up a key, maybe you will want to make it describe.
But we do want the object to affect physics. The character has physics that is affected by the object.
Adding.
What does that mean? Like, this is that.
Okay, so you could try to manually set the velocity instead of adding a force. So you would have your velocity. It's just a
So say it's just a velocity switch. I mean, it's actually in
yeah, so it's already got velocity
And
with
when
lowercase.
pick up different items,
And set it
It's a
it's you
good
just set
question.
up
I don't play this game. It's a Shantai collection.
Take it to the you might add so you might have plus equals because you're adding something to it.
normal or something if you are
Yeah, and then you would have a new vector to say
at the part
5.
we do the movement or other place that will have some difference. You check their state and the differences.
And if you want to, yeah, so that's going to be
you would set turkey mode and regular mode. So turkey mode would have variable regular mode.
I think that's doing it. I can't tell because I didn't exactly know what
And something else you could do if you wanted to kind of completely negate friction, then you could store the velocity that you want it to be, and then on collision exit, when friction is no longer being applied, then you would set it to what you want and kind of add to that. Yeah, that kind of behavior, you could either set your object to be frictionless in your physics material, or you can use a kinematic body and kind of do all that. Yeah. We'll be able to do that.
Yeah.
I think it's important to understand. I'll leave you on.
Yeah.
Right after the yeah, so we can
Oh, I got it. Where these guys push them that way.
so I'm gonna go and
These guys push them that way.